Good afternoon. My name's Steve Blackwell. I'm the worldwide tech lead for manufacturing at AWS. And for the next 20 minutes or so, I want to talk to you about industrial data strategy and how you drive value from your data. Okay? So if we look at the typical use cases for smart manufacturing, everything from real-time visualization around OEE, moving into the applications of advanced analytics, or then moving on even further into looking at how machine learning can be used for predictive and preventive maintenance. It's all about data, and there's a huge amount of data that actually needs to be used. And we really advocate that don't take all your data and just bring it up into the AWS cloud, because you're going to turn your data lake into a data swamp. The real key thing is to make sure that you have the right data architecture and the right data strategy to make the actual data meaningful and turn it into information and turn that information into insights. So let's kind of talk about, a couple of use cases and all the different types of data that you actually need for them. So here's a sample smart factory that I have, okay? No particular process, so we're going to take some raw material from input and we're going to get a product at the end, okay? So the first use case I want to look about is predictive quality. So let's look at the different types of data that we actually need. So in the shop floor environment, we're going to have our MES, we're probably going to have our data historian. Within the cloud, we're probably going to have our ERP system, and we're going to have our MRO or asset management system. So we need to, for doing this predictive quality, we need to bring all this data together. So we need a couple of key components from an infrastructural point of view. First one is we need our data lake. This is where we're going to bring the data. But we also need to get the data from the shop floor up into the cloud. So this is where we talk about AWS from a cloud perspective. It's hybrid cloud, the AWS cloud, and the industrial edge. Okay? So you can see our industrial edge in our factory. And our industrial edge provides a couple of key components. First one is allows us to actually ingest the data from the shop floor systems into the data lake, but also allows us to perform some form of transformation on that data if we need to. And I'll talk about that a little bit further on. Okay? So here we've got our data coming into the cloud. So from our data historians, we've got temperature, line speed, pH as an example. From our MES, we're taking batch, quality. From our ERP system, we've got our production orders. From here, we can actually then build and train a machine learning model. Okay? Because we're talking about quality, we need to actually make sure that the machine learning model is integrated into the actual production process. Latency, performance, and availability is key. So this is where we'll actually deploy the machine learning model back down to the edge. Okay, so it's running on industrial edge. And we can then provide kind of feedback, either closed loop or to actually operators to change how the machine is actually running to make sure that we don't get any quality defects in there. But when we do identify those quality defects, we actually want to take the output of that and bring it back into the cloud so that we can constantly retrain and optimize our model. So we've now got this infrastructure here. We can now build upon it. So let's look at another use case, predictive maintenance. Okay? So we've got more data coming from different data sources. So in this example, we're going to do predictive maintenance of a pump. Okay? So we're going to take RPM and pressure as telemetry values. To do predictive maintenance, you also need all the historical maintenance and tasks that are performed to actually fix it. So that's either sitting in your MRO system or your enterprise asset management system. So we're going to bring that data together into our data lake, train a machine learning model, and deploy it. Now, because it's predictive maintenance, if we're predicting something that's happening in a couple of minutes, a couple of hours, that's not predictive maintenance. We want to predict that the machine's going to fail in 2 weeks, a month, so that we can actually perform a task at the next planned outage. So we can take advantage of clouds, or AWS clouds, on-demand compute and storage, and actually run that model in the cloud. There we are. Next, because we now got this infrastructure in place, we can now build upon it, start adding more data sources in there, and start to look at more applications around OEE, asset condition monitoring, start building dashboards and visualizations. And in some cases, we may actually want to start to deploy real-time applications down to the industrial edge so that we can give the plant operators, line managers, real-time visibility of what's going on. Okay. So as you can see, as you want to build this out to address the use cases that I showed in the previous slide, there's a lot of data that's got to come in from different places, and you've got to be able to manage that data and have the right data to be able to build those analytical models or machine learning models. Okay? So if we look at, I'm sure through the whole of the fair for the last couple of days, you've seen multiple variations of this slide. But, on the left-hand side, we've obviously got the traditional ISO 95 model, and where we want to be is over on the right-hand side, where we've got our OT-IT convergence, and we've got systems talking to systems, and we've got machine learning and AI and generative AI as part of our, applications. But this is not just about, connecting stuff up. It's also about the data. And we've got to move from these traditional, data silos that sit in that ISO 95 model. And if we really want to be in that true Industry 4.0 kind of area, we need to move from this OT-IT convergence and central data lakes to actually having, knowledge-based systems, and having an open data where people can get to access data that they need. To do the jobs that they're trying to do, either to make sure that the plant keeps running, to understand, where all their inventory is, so they don't stop lines when they run out of parts, and so forth. So at AWS, to actually address this, we developed the Industrial Data Fabric framework, which we wanted to simplify the way of being able to get access to your data and use your data, and also make it scalable. Because it's great doing like one use case that takes you like 6 weeks or a couple of months to build, but when you move that use case onto the next line or onto the next factory, you don't want to be spending another 6 weeks, 2 months repeating it again. You basically want to copy and paste and be able to deploy that. So it needs to be scalable from a deployment point of view. So for the Industrial Data Fabric, we've actually created this architectural framework, and we've got 4 layers around it. So we've got ingest, store, contextualize, and act. Okay? So ingest focuses on bringing the data from all your different data sources, be it a PLC, data historian, your SAP environment, your MES. Okay? Your store layer is where you're actually going to store that data, and I'm going to get into that in a minute, because when we talk about storing data, you've got different data types. You've got time series, you've got structured, you've got unstructured data, and then you also need data across different personas. So we're going to have our bronze, silver, and gold. We also then need to contextualize it. Let's talk about our predictive maintenance use case. To do predictive maintenance, you need your time series data, as I just shown in the previous slide, but you also need all the historical maintenance events of what happened and how you fixed it. So you need to create a manufacturing knowledge graph. You need to create the relationships between all the different data sets to make that data into information and into insights. Okay? And then finally, you have the act layer. So you need to be able to get access to that data, but you need to address all the different personas. Your developers, your application builders want to be able to access that data via an API. Your business users are probably going to want to have dashboards or business warehouses to access that data. Also, when you're doing like predictive maintenance, I'll use as the same example, you don't want the machine learning model to generate a JSON file that tells you that machine's going to break and sit in an S3 bucket. That's not really going to drive operational efficiency. What you want to do is actually have the output of that machine learning model create a work order in your maintenance system to tell the maintenance engineer that they need to perform a maintenance task and the next planned outage. That's really where the efficiency comes from application of AI. Okay, so that acts layer is really important about integrating into the business processes and driving workflows. So what this enables us to do is, with the IDF, is really drive scale in deployment of data. So again, We never advocate taking all your data and dumping it into AWS, into your industrial data lake, because you're going to get your industrial data swamp. Very much look at it from a use case by use case perspective. And what you see is over time, you start with a small amount of data for that one particular use case. You then move on to your next use case, and you may need a couple more data sets to address those. And then when you get to your fourth, fifth, sixth use case, you'll find that you probably already have the data that you need in your data lake, and you actually start to get value by the way you're addressing it. So now we've talked about kind of the why. Let's start talking about, how and what that strategy should look like, okay? So here's the architectural blueprint that actually supports that, okay? So we've broken these down into individual building blocks that address each of the needs of bringing up the data from the shop floor or those systems up into the cloud, how we actually integrate it into the dashboards, contextualize it, apply analytics and machine learning that's constantly enriching that, but also provide feedback down into the shop floor within process control and so forth. So looking at it from a data perspective, this is our data architecture, okay? And when we're talking about, the data, we see data, as I said, across three views. Our time series data, our structured data, and our unstructured data. But data has use across different use cases. So for example, we talk about hot data, okay? So this is when data needs near enough real time from point of creation to the point of, probably 5-10 minutes. These are your dashboards that are running, on the work centers, informing the operator exactly what's happening in the machines they're actually running, okay? After 5 minutes, they no longer need that visibility of data, okay? So this is where we then move on to our warm data use cases, and we can actually address them in the cloud. So this is your near real time. So the view of your data or the fidelity of the data only needs to be from like 5 minutes after it's created to potentially kind of end of shift, end of day point of view. It's still online, but you don't need high value access to it, or real time access, I should say. And then finally, we then have cold data. Okay, so you no longer need the data online. This is where you're going to start actually creating queries on the data and pull in particular data sets to build information models. So when we talk about cold data, we have bronze, silver, and gold. And bronze, silver, and gold is specific to different personas. Okay, so your bronze data is the raw data. You've performed no ETLs or modifications to it, okay? And obviously that goes across the 3 different data sets. Your data scientists come in, or your data engineers. They actually want to start addressing problems like predictive maintenance or predictive quality. So they now need to start curating data to create a specific data set where they're either going to train a machine learning model or they're going to run analytics across it. So this is their silver data, okay? We then have our business users. So our business users, they actually want the results of that machine learning inference or the results of that analytics. So this is where our gold data comes in, okay? So our gold data is what the business are actually going to be using, okay? So as you can see, data, when you look at your data strategy, you need to look at it from a point of view of who's consuming it and what applications actually is going to be used for. It's going to be used for real time on the shop floor, hot, or is going to be more used for analytics, reporting, take advantage of the AWS cloud, and think about, do we need to provide it for persona, for our data scientists, or is it more for kind of our end users, and therefore we need a data warehouse? So as a reference, just mapping, this is what it looks like from industrial data reference architecture. The reason I say reference in quotations is we have over 200 services, 2,000 features, and we have multiple databases and data storage services. So we also have our partners solutions as well. So for example, from a gold point of view, we have Amazon Redshift, but also have partners like Snowflake, who's in the kiosk. So there's not a one fits all. It's kind of, you can pick and place as you need. For example, from a hot data point of view, we have AWS IoT Sitewise Edge to run the edge. We also have partners like HighByte that can provide that capability, and like Seek for real-time analytics. So let's talk about another challenge that you'll need to address as part of your data strategy, which is about information model challenges. So we've got two machines, okay? One machine is here in Europe, another machine is here in the US, and they're being bought a couple of years apart, but they're from the same machine vendor, okay? So one machine, when it talks about how it's running, has a status of up, running, down, error, idle, stopped. The second machine has exactly the same statuses, but it uses a different variable. So up is in progress, down is stopped, idle is idle, okay? What we want is when our business users or our data scientists come to actually use that data, we want them to be able to not have to perform some form of data wrangling to interpret that data. We want an information model in place that allows us to be able to know exactly what that information is. Okay? So for example, we bring that into our database. We've got two machines, exactly the same machine type, but one says machine X says running, the other one says machine in progress, which means that there may be some interpretation of what's going on. Similar, let's look at telemetry, and I'm using temperature, okay? One is actually outputting 109.4, the other one is actually 43. What you'll find is actually one's in Fahrenheit, one's in centigrade. They're exactly the same value, but they've been interpreted different because they have different KPIs associated to it. So what we need to do is, as we bring that data into the cloud, we need to make sure that we're adhering to an information model. So how do we actually achieve that? We do it at the point of ingestion, so as close to the data source as possible. And this is why the industrial edge and enrichment of the data is kind of key. So let's just focus on kind of time series data. And within this architecture, we've actually broken apart the way that we actually bring the data in. So we're agnostic of where the data is stored and the communication protocol it actually uses. So it doesn't matter if it's using OPC UA, OPC DA, Ethernet, Modbus. We have a separate connector that allows us to be able to talk to the actual machine. What we then have is, next to that, we then have what's known as our transform routing mechanism that we put in place that actually takes the data that's actually ingesting and actually adheres it to the information model that we need to apply. So if we standardize on machine status as running and our temperature as centigrade, anything that doesn't adhere to that, we can do it as soon as we ingest the data. So when it gets into our industrial data lake, everybody knows that the information around temperature is actually in centigrade. Okay? The other thing we're doing here is we want to make sure that this is actually scalable. So this information model is stored in the cloud in a central configuration database, and then allows you to actually take it and deploy it down to your individual industrial edges machines so that you can actually standardize and actually manage this over your multiple factories and actual lines. So what does this actually look like? So for the machine that we've actually standardized is using running and centigrade, the information just passes all the way through, no transformation needed. The other machine that uses in progress and Fahrenheit, as we bring that data in, we perform those transforms and then send it up into the cloud. So then when our users, our data scientists or our business users actually go to use that data, they have confidence and know that the information is what they actually expect, and they're not going to get any errors or have to do any additional work to actually transform that. Okay. So for those of you that like pretty pictures and so forth, I kind of build out diagram that I showed you earlier on that had those different building blocks, what does that actually look like? Because not everybody is going to use AWS services. You also have our partners here. So this is our Industrial Data Fabric reference architecture that shows how everything fits together from a information and data strategy point of view, enabling you to bring the data into the cloud, give the tools to the relevant users, either your data scientists, your operational engineers, your manufacturing engineers, or your process engineers, or your business users to be able to actually consume it. Okay? With that, I want to say thank you. And if anything I've said of interest is want to follow up, we do have a IDF kiosk in the booth where some of my colleagues can go a lot more into detail around what I've been talking about. Also, our partners that you saw on the previous slide are here, so please go talk to them. Over that, thank you.